Good afternoon, Los Angeles. This is David De Los Reyes. I am now on lesson number 22. I am now on lesson number 22 on integral calculus on my channel. Okay. My topic for today will be a continuation of the evaluation of problems under inverse trigonometric functions. Still, the topic is inverse trigonometric functions. Some more examples before we will proceed with the logarithmic integration. Okay? I give you, I think, 3 examples yesterday. I will give you 3 more. So I think that's just more than good enough for the evaluation examples for inverse trigonometric function evaluation. Okay, let's proceed so we don't waste time. Okay. Example number 1. The integral of dx over the square root. We are given an algebraic function inside. It is 5 plus 4x minus x squared. To solve for this problem, always think of the formula and how to take the integral of an inverse function. So we are only given 2 formulas. It's either arcsine or arctangent, right? So we will do some manipulations to bring out the solution of example number 1 for it to fall under either arcsine or arctangent. Okay, let's proceed with the solution. 5 plus 4x minus x squared is actually, we could manipulate this one, or we can manipulate this one for it to fall under a trinomial perfect, sorry for this one, perfect, should be letter P, trinomial perfect square. So actually, it's a problem of algebra. Okay, the continuation of this, for it to fall under trinomial perfect square, I did this. I put 5 and 4 here, minus open quantity of x squared minus 4x plus 4. Why I did that? Okay. If we try to expand this one, okay, we added 4 here, right? But when we expand this one, this is negative, this is plus 4. So minus 1 times plus 4 is minus 4. So actually, this 4 here cancel with this. But we could do that, right? Actually, we didn't add anything inside. We just add something for it to fall under a trinomial perfect square. And minus 1 times x squared is minus x squared. Minus 1 times minus 4x is actually 4x. So actually, if we expand this one, it is still the same as the given problem, right? But we could do this. 5 plus 4 is actually 3 squared. That's 9. And the factor of this is actually x minus 2 quantity squared. If we try to factor out this one, it should be x minus 2 quantity squared. Okay? Let's check. If we expand this one, this will be equal to x squared. Middle term is minus 2x times 2, that is minus 4x. Pure constant is minus 2 quantity squared, this is plus 4. So this one is actually this. Right? Right? So x squared minus 4x plus 4 can be written as x minus 2 quantity squared. Why I did that? I am thinking of the arcsine solution. It seems this form here is similar to the integral of dv over a squared minus b squared. Okay? And if we try to observe it, a squared is actually 3. Take the square root of both sides, a will be 3. Right? b square is x minus 2 quantity square. Take the square root of both sides. b will be equal to x minus 2. Right? And here we can compute now for the b because we are now given b in terms of an algebraic function. db is equal to dx. The differential of x is dx. The differential of minus 2 is 0, so this is minus 0. Or db is equal to dx. And this is exact. This db here is actually same as this. So, our assumption that the solution is under arc sine was correct. So, to solve the integral of this, what is the integral of an arc sine? It is arc sine of b over a plus c. Right? We have computed already for the value of b. We have computed for the value of a. So, substituting, final answer now. The integral of dx over the square root of 5 plus 4x minus x squared equal to arc sine of what is b? b is x minus 2. Right? And what is a? It is 3 plus c. That's the final answer. As simple as that one. So actually the solution of example number 1 is with the help of algebra. If we do not know how to complete a trinomial perfect square, we are gone. Right? So, calculus can be solved by using with the aid of your knowledge of algebra. Without your knowledge of algebra, you're gone. That's why I told you before the prerequisite of the higher mathematics is algebra and trigonometry. Plus perseverance. If you don't persevere in the so-called simplification in a correct manner, you're gone. Right? So it's nice to be, what they call this, systematic in the solution. Okay. Example number 2. The integral of x squared minus 4 over x squared plus 4 dx equal to. It's an algebraic equation still. I will erase this one. So our solution here will be clear. Okay? To bring out the solution, we divide first. Why we divide first? It seems the highest power of x on the denominator, or numerator rather, is same as the highest power of x on the denominator. Okay? So we divide first. Longhand division. You don't use your calculator. It is longhand. We longhand divide this on the magnetic board. Denominator, numerator, we divide. Okay? X squared minus 4 divided by x squared plus 4. Right? We got the numerator, we divide by the denominator. First answer here will be 1. Or first dividend. 1. 1 times x squared is x squared. 1 times 4 is plus 4. The operation is subtraction, right? Right? That's longhand. X squared minus x squared will be 0. Minus 4 minus minus 4. Minus 4 minus 4 is minus 8. This is now 0. So actually our remainder is minus 8. So the given problem can be written as the integral of x squared minus 4 over x squared plus 4 dx equal to the integral. Okay? After the division, we bring out what comes out. The first dividend is the integral of open bracket 1. We got the first answer dividend 1 here. Okay? Plus our remainder. And what is our remainder? It is minus 8 over x squared plus 4 close bracket dx. Then try to expand. 1 times dx is the integral of dx. Okay? Second term, we got an 8 dx all over x squared plus 4. This is presented by negative sign. 8 is constant. We bring it out automatically. So this should be, the expansion will be minus 8. The integral of dx over. Okay, we'll go automatic a little bit. Okay, we'll go automatic a little bit. X square will be, 4 is actually 2 square. Okay, and x square is actually x quantity square. I am thinking of the arctangent solution because it seems this is similar to the form the integral of bb all over a square plus b square, right? So actually a square is actually 2. Taking the square root of both sides, a will be 2. B square is x square. Taking the square root of both sides, they are both perfect square. B is equal to x. Compute for the value of dB. dB is equal to dx. It is exact. Why exact? Try to notice the given numerator. It is dx. Same as this. So our assumption that the solution is under arctangent was correct. Okay, proceeding with the solution now. The integral of the differential of x will just be simply x. If this integral sign goes next the differential sign, they will cancel out each other. Okay? So it will just be simply x. Minus 8. The integral of dv over a square plus b square. And what is the formula for taking the value of dv over this? It is 1 over a arctangent of b over a plus c. So we will just follow this one. So this should be minus 8, okay, times 1 over a, 1 over 2. A is 2, right? We're following this. Arctangent of b. But what is b? It is x. And what is a? It is 2 plus c. 8 over 2 is 4. So the final answer, x 8 over times 1/2 is 4, arctangent of x over 2 plus c. That's the final answer for number 2. Right? So the final answer came out after the long division. Right? After the long division. Because what comes out will be two terms that are both integrable. The first one is just exact differential. The second one falls under the arctangent. That's why our topic for today is inverse trigonometric function. And that inverse trigonometric function is arctangent. Okay, that's example number 2. I'm checking my camera. Okay, example number 2. I will erase this one so it looks nice on the screen, right? Okay, example number 3. Before we lock out of memory. Example number 3, the integral of secant theta, tangent theta, differential theta over 1 plus 4 secant square of theta, 4 secant square of theta. We got a plus sign underneath. We got a plus sign, so maybe this falls under arctangent, right? But we must have to do something for it to fall under arctangent. So actually, the integral of secant theta, tangent theta, differential theta can be written as 1 is just 1 square, and 4 secant square of theta can be written as 2 secant of theta quantity square. And this is now similar to the integral of dv over a square plus b square. Like, they look similar. So, if we compare this one, a square will be 1. Take the square root of both sides. A will be 1, either plus or minus 1, but we will use plus 1. B square is 2 secant of theta quantity square. B square is 2 secant theta quantity square. They are both a perfect square. Taking the square root, the value of B will be twice secant of theta. Let's try to compute for the value of dB. Or just use your knowledge of differential calculus. The differential of B is dB. The differential of 2 secant of theta, okay, it will be 2, okay, A constant in a function. So 2 times the differential of the function. Second, what is the differential of secant of theta? It is secant of theta, tangent of theta, differential of theta. It is not exact. Why not exact? We are missing the value 2. Okay? We got no 2 in here, no 2. So there's no problem. We could offset this one by placing 1/2 outside, the reciprocal of 2. Therefore now, the integral of secant of theta, tangent of theta, all over 1 plus 4 secant square of theta is equal to, finally, it falls under arctangent. It is 1 over A, arctangent of B over A plus C. So this should be equal to y 1 over 1. We are following this. It is 1. What is A? A is 1, right? So this is over 1. Times, why we got the 1/2 here? Because we will insert these 2 here inside on the complete differential. So to offset that one, we will place the reciprocal of 2. So this is 1/2 arctangent, okay, of B over A. B is 2 twice secant of theta, all over A, 1, this is plus C. 1 times 1 is 1, 1 times 2 is 2, so the coefficient of the final answer will be 1/2. Arctangent, 2 secant of theta over 1 is just 2 secant of theta. This is plus C. That's the final answer. Okay? We put 1/2 here because the complete differential inside should have the value 2. Okay? We are doing that in our integration. Okay, let's take the last example for today. Last example, the integral of cotangent of theta, differential theta, over the square root of 9 minus natural logarithm square of sine of theta equal to. We are given the value of a function inside the radical sign to be under the natural logarithm, and not only under natural logarithm, it is still under trigonometric function. So it looks complicated on the first look, but don't be afraid, we could solve this. Okay? Okay, let's proceed with the solution. This should be equal to the integral cotangent of theta, differential theta. 9 can be written as 3 square, and natural logarithm square of sine of theta can be written as natural logarithm of sine theta to the second power. And this looks similar to the form the integral of dv over the square root of a square minus b square. It seems this is under arc sine. Okay, let's do our verification. A square, this should be A. This is A. This is A. By comparison, 3 square is, sorry for that one. 3 square is A square, or simply A square is 3 square. Take the square root of both sides. A will be 3. We use the positive sign. And B square is natural logarithm of sine of theta quantity square. Take the square root of both sides. They are both perfect square. So B will be equal to the natural logarithm of sine of theta. A little bit complicated. This is natural logarithm, this is sine of theta, but don't be afraid of that. The value of a term inside the natural logarithm is sine of theta, and don't be afraid with the sine of theta. We know how to differentiate that one. B is equal to natural logarithm of sine of theta, taking the differential of both sides. The differential of B is just dv. The differential of natural logarithm is 1 over u, 1 over sine of theta. The value of u for this natural logarithm is sine of theta, times du. And what is the differential or derivative of sine? That's why I told you don't be afraid. We know how to differentiate sine of theta. It will be cosine of theta times differential of theta. 1 times cosine of theta differential theta over sine of theta. Cosine over sine is actually cotangent. Okay? Times differential theta. And this is exact. This cotangent of theta is actually same as this. Right? So our assumption that the solution for this one is under natural logarithm was correct. So what will come out? We will just take the integral by using this, and this falls under arc sine. So this should be arc sine of b. What is b? Natural logarithm of sine of theta. And what is a? It is 3. This is plus c. That's the final answer. I will repeat it for the last time. The integral of cotangent of theta differential theta over the square root of 9 minus natural logarithm square of sine of theta equal to arc sine, open quantity, natural logarithm sine of theta over 3. This is plus c. That's the final answer. As simple as that one. So you see, guys, we are running smooth. Okay? We are going from down up gradually. So we are now maybe familiar with the integration of inverse trigonometric functions. So when we go with the application problems, it's a mix-up of all things. Use your knowledge of all the integration formulas, whatever will come out. Okay? I think, ladies and gentlemen, that's more than good enough for the integration of inverse trigonometric functions. I've given you 7 examples. I think that's just more than good enough. Okay? If you like it, guys, please click like. Be nice to me. I'm just joking. If you want to share it, please click share, please. And if you want to subscribe to my channel, please click subscribe. This is for you guys who are taking integral calculus. Just take it easy. We are doing it gradually, but we are going upward and forward. When we go to the applications, we've got no more problems because we are now familiar with all the integration, whatever will come out. Good afternoon, Los Angeles. Thank you.